So we've learned how to take a filtered data set, group it by year, and record the mean income in each year. But maybe we don't want to summarize by the mean. Maybe we'd like to summarize by the weighted mean. Let's consider the weighted mean income, where each person doesn't have equal weight. Some people represent lots of people in the population, while others in the sample represent only a few people. We'll cover the ideas behind this next week in class when we discuss sampling. But for now, let's just learn how to use a weighted mean. Just like the mean function, there's also a weighted mean function. If you want to learn about it, you can type $weighted mean in your console, and you'll get to the help file for weighted mean. You see that it has two key arguments. It has x and w. If you scroll down, you'll see examples for how they're used. In this case, we already know how they're used, so I'm going to just explain it here. X is the variable being summarized, ink wage. W is going to be the name of the variable that corresponds to the sampling weight. In our case, it's ASEC weight, the annual social and economic supplement weight. And so now if we run this code, we will get a result that's grouped by year and has a weighted mean summary. Now you might further say, well, the mean may be a poor summary of incomes. After all, incomes have a long upper tail. If you have one person whose income is like millions of dollars, it can totally drive the entire mean statistic. Maybe we would rather summarize by the median income, the value such that 50% of people have incomes lower than that value. But how do we do that in a survey where we have weights that we need to incorporate? We need a weighted median. The weighted median is the value such that 50% of the weight falls on people with lower incomes. Unfortunately, there's not an easy weighted median function built into your base package of R. So instead, we're going to use a new function in a new package. That package is the HMIS package, HMISC. If you haven't installed it yet, you can install it like with all packages, install.packages HMIS. Once you do that, you'll have the package ready to go. We're not going to load this package the same way that we've loaded other packages. Why? This is a big package with lots of functions. Some of them have the same name as functions that exist in the tidyverse package. So you could have a collision where R would know which function to use, the one from tidyverse or the one from HMIS. And this could be confusing. What it'll end up doing is using the function from the package that was loaded more recently. But then you'd have to remember what order to load the packages in. Instead of loading the entire HMIS package, as we would do by typing library HMIS, we will instead load just one function from that package when we're ready to use that function. This is going to be the weighted quantile function. So I'm going to go over to the course website and copy some code. Okay, so to load the weighted quantile function from the HMIS package, we use these two colon signs in series. So you type HMIS : and then the function within HMIS that you want to use. We then proceed by passing arguments to that function just as you would for any other function. So in this case, the weighted quantiles we want to produce are going to be the 10th percentile, the 50th percentile, or median, and the 90th percentile. You can read about the HMIS package to see how this function works, but here's how it works in our setting. We take our filtered data, we're going to group by year, and then within each year we're going to produce 3 summary statistics, the 10th, 50th, and 90th percentiles. Those are percentiles of the ink wage variable, where each observation is weighted by the ASEC weight, and the percentiles are defined by this probs argument. You'll note that I've added this .groups equals drop argument at the bottom. That's just because when you run it without this argument, then the tidyverse spits back a warning that you might need to tell it how to handle the groups. After it's already done this summarizing, you don't need the groups anymore. You've reduced to a data frame where there's just one row per group. So we're going to tell it to drop the groups at the end. Let's see what happens when I run this whole line of code. So we've now created a new object that's over here in our global environment. It's the summarized object. If we look at the summarized object, we'll see what we have. Where we started out with our filtered data that had 1 row per person, we now have 1 row per year. For each year, we have 3 summary statistics, the 10th, 50th, and 90th percentiles. We created these variables with P10 equals the function that makes the 10th percentile, P50 equals the function that makes the 50th percentile, and P90 equals the function that makes the 90th percentile. So once you've run this code, you now have 3 summary statistics in each year.